I'm Conrad Metcalf with the New York Building Performance Contractors Association. We are a 20-year-old nonprofit trade association working on behalf of our members, who are primarily energy efficiency contracting companies, building science consultants, and Energy Star raters, and miscellaneous stakeholders. I welcome you to this first in a series of 3 webinars to promote the deployment of air source heat pumps. These webinars will be followed by a hands-on workshop where participants will be able to get firsthand experience installing air source heat pumps. We have almost 100 registered today, so I'll provide just a quick look forward. Webinar 2 will be held next Wednesday at this time. We will cover the air source heat pump as an integral part of a comfortable and energy efficient home. We'll make the business case for expanding the adoption of air source heat pumps as a way of staying on the leading edge and honing a new market niche. We'll look at the typical efficiencies of cold climate air source heat pumps, and we'll explain how building efficiency relates to sizing requirements. Very important. Webinar 3 will be held on August 19th, where we'll examine the most common installation errors uncovered during the QA inspections. And we'll discuss key best practices for design, for equipment selection, for installation, and control setup as well. Then on August 22nd, we'll hold a full day workshop for HVAC installers, where you can get hands-on experience along with, based on the installation protocols, which are based on the most common errors observed during QA inspections and knowledge that we've gleaned over the years. This is really valuable information, and I'll just mention that space for this event is limited to 8 participants, but we would like to run it more than once, and so that will depend on registration numbers and market demand and such. We'd really like to thank HeatSmart Tompkins today for allowing us to chart this course to deliver on the promise of a clean energy future. We have Brian Eden on the line, and I'd like to personally express my appreciation for Brian's tireless efforts to improve the trajectory of for clean energy here in New York. We also have John Herod on the line. He'll be leading the charge today. John has been on the cutting edge of building performance for more than 20 years, and he's the only home performance contractor I know in New York that has a PhD, and I know a lot of contractors. John is the driving force behind Snug Planet, which is a full-service home performance contractor based in Ithaca, New York. So I'll be handing over control to John in just a minute, but first I wanted to mention a few housekeeping points. We'll be answering your questions towards the end, but you can feel free to ask them at any time. There will also be opportunities during John's presentation to share your thoughts in the chat window, and I would encourage you to do so, as it's really going to require all hands on deck to make clean energy a reality in New York State. Also, we'll be sending out today's slide deck to the attendees, and I urge you to help NYSERDA improve its workforce training programs by completing the brief pre-webinar survey if you've not already done that. We'll send out the link to the survey with the slide deck. If you're attending multiple webinars, you only need to fill this out one time. So, yes, next I'm going to hand the reins over to John Herod. And yes, John, you are there.
All right. Thanks so much, Conrad. Yeah, so the topic of today's webinar is why every home will need a heat pump. And I hope by the end of this, you will see the potential there. When we talk about every home, we are talking about the 5+ million homes in New York State. And when we're talking about heat pumps, we're talking about cold climate heat pumps that are capable of meeting the full needs of the home down to very cold temperatures. And we expect that this transition is going to occur very rapidly. I think given the urgency of the climate situation and the ambitious goals that New York State has laid out, we can expect that this is going to happen in the next 15 to 20 years during the working life of most of the people on this call. Just to tell you a little bit more about me, I trained as a biologist. I got into home performance in 2001. Initially, I started out doing energy audits and envelope work. I've blown cellulose in a lot of attics and encapsulated a bunch of crawl spaces. And a really formative moment for me was around 2012, I got involved in a NYSERDA grant to do deep energy retrofits. These were projects where we took the improvements to the envelope to the extreme and, wrapped homes in 2 inches of rigid foam, redid the siding, replaced the windows, did everything we could to make the envelope as efficient as possible. And then we tracked the savings. And what we found is that in these houses where we, in many cases, spent over $100,000, we achieved 65, 75% reduction in energy use. And it occurred to me that this was a lot of work to not get it all the way to zero. And it made me start to rethink my approach. And does it make sense to focus so heavily on the envelope? Is there a better way? And that's when I started getting really interested in heat pumps. And right around this time, cold climate heat pumps were really emerging as a technology appropriate to our area. And that's when I started learning and training about heat pumps. It was a major change in the business direction of our company, but now heat pumps account for more than half the volume of our work. And especially since I've had a little time on my hands during the pause, I realized that I really wanted to do more writing and share what I've learned about heat pumps and about sustainability in general. So along with the slides for this webinar, I'm going to be sending out an article I wrote for Building Performance Journal on the do's and don'ts of cold climate heat pumps. By the end of this webinar, we hope that you'll be able to articulate the benefits of cold climate heat pumps and to talk about them with homeowners, explain how they can benefit homeowners and New York State in general. We want to start to familiarize you with the very rich incentives and rebates that are available to help make these technologies more accessible and more affordable for people. And then look at some of the situations where air source heat pumps can be an absolute home run. Why are we going so heavily into cold climate heat pumps right now? The big driving force for a lot of us is the idea of decarbonization, getting our economy away from fossil fuels, and in doing so help to protect from the worst effects of climate change. And this ties into the idea of beneficial electrification, the idea that as we move our heating for buildings and our transportation away from fossil fuels and towards electric solutions, that gives us a great pathway to get to zero emissions because we can make that electricity renewably with wind and solar. Another big motivation here is energy affordability. Heat pumps offer a very affordable alternative to particularly expensive fuels like oil, propane, and electric resistance. They offer an opportunity to improve comfort and health for people in New York State. And I think, I hope a lot of people here will also see this as a huge business opportunity. And if you're a contractor or you're interested in getting into contracting and you're interested in doing something that has huge growth potential and a lot of benefits for society as a whole, I hope you'll consider adding heat pumps to your offerings. So, just a little bit more about kind of the big why of why we're pushing for this. Carbon dioxide is a naturally occurring molecule that reflects heat from that's being emitted by the Earth back towards the Earth. And so some of it's necessary to keep the Earth at a habitable temperature range. But what scientists have done is reconstruct the concentrations of carbon dioxide over time, going back thousands of years. This graph just shows the last 10,000 years or so. They've done this using ice cores from the glaciers, but more recently from samples they've been collecting in different locations around the world, like at the famous observatory at Mauna Loa in Hawaii. And what they found is that in pre-industrial times, the concentrations of carbon dioxide were low. They were under 300 parts per million. And just in the last couple hundred years, they've increased dramatically, from under 300 to now over 400 parts per million. This graph doesn't go all the way to the modern moment, but right now the concentrations of CO2 are well over 400 parts per million. So in this case, they are literally off the chart. Where is all this carbon dioxide coming from? A lot of it is coming from the burning of fossil fuels. So if we look at this timeline, we can see back in the early industrial revolution that coal started to replace wood. That was a solution to a major environmental crisis of the time, because forests, both in North America and Europe and other parts of the world, were becoming heavily depleted. Petroleum first started to be used in a wide scale in the middle of the 19th century. And more recently, natural gas has become one of the dominant forms of fossil fuel. So fossil fuel use has increased over time. This chart shows CO2 concentrations on the red line and global temperatures in this blue chart. And you can see that the global temperatures are increasing in parallel with carbon dioxide concentrations. And they're continuing to do so, leading to other effects, including increased hurricanes, droughts, and heat waves. So New York State has really taken some leadership in trying to address this problem. And one of the major pieces of legislation dealing with this is the CLCPA, the Climate Leadership and Community Protection Act. And that's part of what's driving our effort here today. Starting right now, New York is in a push to create more than 150,000 clean energy jobs. At the same time, we're looking to transition our electric generation away from fossil fuels by building more and more distributed solar, community solar. By 2030, we're hoping to get 70% of our electricity from renewable energy, continuing to add offshore wind, so that by 2040, our electric grid is 100% powered by clean electricity. And in the process, we're shooting to achieve by 2050 an 85% reduction in fossil fuel and carbon dioxide emissions. Where does our work as residential contractors fit in this effort? Turns out that combustion of fossil fuel in buildings accounts for about 30% of New York State emissions. And so that's the piece that we're going to be working on today. Other people are working on electrifying our transportation, improving our electricity generation, and so on. For homes and buildings, there's a really clear path to get to zero emissions. We want to increase efficiency. A lot of the work we've been doing as home performance contractors and energy auditors is to increase the efficiency of buildings, reduce the requirements for heating and cooling. We want to replace fossil fuel equipment, that's natural gas and oil and propane boilers, with heat pumps. And at the same time, transition to 100% renewable grid. So this is sometimes described as kind of a sequential pathway, but in practice, we can proceed in parallel with all these three efforts. And in doing so, we can rapidly continue to cut our state's emissions. Another reason that this is important to New York State, and something that I'm really passionate about personally, is that energy costs are a big part of the cost of living for low and moderate income households. And we see this in a lot of different contexts throughout the state. On the top here, we have an elder home that's entirely heated by electric resistance. And the costs there are quite high. On the bottom, we have a mobile home typical of a lot of the lower income housing in rural New York State. These are oftentimes heated by some combination of electric resistance, oil, kerosene, and propane. And those are also very expensive to heat. And it turns out that heating costs are a much higher proportion of household budgets for low-income households. And so by helping reduce their energy costs, we can help alleviate poverty. This chart shows the relative costs of different types of heating for your house. These costs are going to vary by region, depending on your local energy costs and your local electric utility. But what we can see, and this holds true throughout the state, is that electric baseboard, propane, and fuel oil are very expensive ways to heat your home. Natural gas is cheaper, and air source heat pumps are cheaper still. I did not include geothermal in this graph, but as we'll see a little bit later, geothermal is a very efficient form of renewable all-electric heating, and that can provide even lower costs relative to these other sources. Another reason that heat pumps can be terrific problem solvers is that they can do a lot to improve comfort and air quality in people's homes. One of the common problems that we run into as home performance contractors is the bonus room, or some people refer to them as the frog, the freezing room over the garage. This is something that people do to add a little extra space. Sometimes it's a home office or a playroom. But because it's so exposed and because it's so far from the main heating plane of the house, it's very commonly a site of a lot of comfort problems. Because of the flexibility of heat pumps and ductless heat pumps in particular, they can be a great solution to making those spaces more comfortable and effectively adding more useful living space to the house. Heat pumps can also provide, very high quality air conditioning. And as people are spending more time at home and as we're dealing with hotter and more humid summers, adding that high quality and high efficiency air conditioning is going to be another big opportunity to improve people's lives. By getting combustion byproducts out of the house, so things like carbon monoxide, we can improve air quality. A lot of issues in the house are also created by shoddy ductwork, leaky ductwork that brings in not just uncomfortably hot or cold air, but dusty air. And ductless systems allow us to eliminate that whole source of air leakage and contaminants. And in addition, heat pumps, by cooling, can provide dehumidification. Now, the three key parts of indoor air quality work as it relates to HVAC are dehumidification, filtration, and ventilation. And heat pumps, especially ductless heat pumps, don't do a great job of filtration, and they don't bring in any outdoor ventilation air. So that's an area that we still need to continue to work on. But there are some solutions that are emerging in that area. To think for a moment about the market opportunity that we have here, I think it's really huge when it comes to heat pumps. There are almost 2 million households in New York State that are heating with oil, propane, or electric resistance, these very expensive heating fuels. We have almost half our housing stock cooling with window units and another 15% that have no air conditioning at all. So that's over 3 million households. And because heating systems wear out, at least half of those are going to require replacement in the next 15 years. And so if we can be there at the moment that the life cycle of the current heating system ends and we can offer a renewable heat pump option, we can do a lot to rapidly increase the implementation of heat pumps. Another piece of this opportunity, and one that I hope you'll all get familiar with, are the generous incentives that are present statewide. And we'll be going into these in a little bit more detail, but currently the utilities and NYSERDA are both offering programs that make heat pumps a lot more affordable and accessible to people of all income levels. They also provide an opportunity to build up bigger work scopes compared to what you would be getting if you were just doing a simple furnace swap, for example. So we're going to be discussing kind of three major areas of technology. Our focus is really today going to be on air source heat pumps, but we're going to briefly mention geothermal heat pumps and heat pump water heaters. And between the three of these, we are able to provide high efficiency, all electric heating and cooling and water heating to all households in New York State. There are places where heat pump water heaters aren't actually the ideal solution, and we can talk about that a little bit as well. But for most of the houses that we deal with, one or two of these technologies is going to be really great. This was a graphic that was developed by our local cooperative extension, and I really like it because it helps explain the magic of heat pumps in a way that I find to be pretty accessible. People often ask, well, how do you get heat out of -10-degree air? And the secret is understanding the refrigerant cycle. And what a heat pump does is changes the pressures of this refrigerant as it moves throughout the system, so that at some pressures, it can absorb heat even from very cold air. The compressor, which is kind of the heart of the system, compresses that gas, raises its temperature, and now it can release that higher temperature. It can release the heat from the higher temperature refrigerant inside the house. And so this is how it works in heating mode, absorbing heat from the cold air outside, releasing it into the warm house. In the summertime, that process reverses itself, and now it's absorbing heat inside and releasing it outside the house. And in the process, it's also removing humidity from the air. So I could spend an entire 50 minutes going into the refrigerant cycle, and at the end of it, you'd probably still want to go and watch some YouTube videos and try and get your head around it. It's a really incredibly fascinating process, and there's a lot to learn, a lot of nuances to it. But it's the heart of heat pumps, and it's something that I think we're all going to need to become more familiar with going forward. I'm going to start by talking today about air source heat pumps and mini splits in particular. This is one of the most common configurations of a ductless heat pump, a single outdoor unit connected to a single high wall unit. The basic components of the air source heat pump are the outdoor unit, which contains the compressor, most of the controls, and the outdoor heat exchanger, which in the wintertime is the evaporator, in the summertime it's the condensing coil. That's connected to the indoor unit with piping that carries the refrigerant in between the units. There's an indoor unit which contains the indoor heat exchanger as well as a blower fan. And then each system is going to have controls that allow the occupants to adjust it for their comfort needs. The outdoor units typically look something like this. Depending on the exact configuration, you might have a single fan. That's typical of units up to about 2.5 tons of capacity, or a dual fan for units that are in the 3-ton up to, in some cases, a 4-ton capacity range. Each of these can be connected to one or more units depending on the equipment. And those are connected by these refrigerant lines, typically hidden inside these line set covers. A couple of the most common indoor unit types are the high wall unit on the right. I would say that probably 3/4 or more of the units we install are these high wall units. They're very popular, and people often have free space higher on their walls, and so that's often where they end up. But these low wall units, or sometimes called floor units, are also very popular. They have a look that kind of resembles a traditional radiator, and they fill that same space in the room. Those are really nice because they deliver their conditioned air low in the room, which is ideally what you'd want in a heating situation. But there are actually a lot more options available. In addition to high wall units of different shapes and colors, There are ceiling cassettes, which are mounted, recessed into a ceiling and provide a four-way airflow. There are these compact ducted units that you see in the middle here. Some of them are what we call low static units that can provide airflow to just a very short duct work system. Some of them have enough static to push air through a much more extensive ductwork system. There are some creative things like this picture frame indoor unit that LG offers that is essentially a blower and a heat exchanger hidden behind a picture frame in which you supply the picture. And I think the thing that's really going to allow this type of work to scale are these vertical air handlers, or multi-position air handlers as they're sometimes called. These are very comparable in their form factor to a natural gas furnace, and when the sizing and the ductwork line up, they can oftentimes be a direct replacement for a fossil fuel furnace. One of the things that we have to address when we're talking about heat pumps with customers is some of the negative perceptions they may have had from the older generation of heat pumps, which were never very common in our area, although they're a lot more common in the Mid-Atlantic and the South. People will say, oh, you know, these heat pumps, they're really noisy. They don't work very well below about 40 degrees. We end up relying on our electric strip resistance heat, and so our fuel bills are just exorbitant. And a lot of these things were true of that older generation of heat pumps, and especially when the applications and the control setups weren't done correctly. The new generation of heat pumps is vastly superior. This is a performance graph for a Mitsubishi cold climate heat pump. And what it shows here in the gray is the performance curve of a standard heat pump, kind of the modern generation of the old clunker that we looked at in the last picture. And you can see as we get below 47 degrees, its temperature output, its heating capacity falls off dramatically. So the more heat you would need, the less the system produces. And that's part of why most heat pumps of that older generation would switch over to some kind of backup heating somewhere around 30 to 40 degrees. And below that, you'd be relying heavily on electric resistance heat or on a fossil fuel. Cold climate heat pumps, which first started to become common in our area about 10 years ago, and you know, now have a really strong track record in our region, maintain their performance at 100% all the way down to 5 degrees or so. Below that, they start to fall off, but they still maintain a significant portion of their output all the way down to temperatures that we rarely encounter in our region. So it's important to understand the performance of these systems at low temperatures when you're designing a system, but the technology is proven and the heating curves are well known, so we can take that into account when we're designing these systems. Another technology that I think it's worth becoming familiar with is what we call a dual fuel or a hybrid heat pump. And this is what I was describing before. It is a heat pump that operates down to a cutoff point. Depending on the system, it might be 20 degrees, it might be 35 degrees. And below that, you have a backup heating system, typically a fossil fuel-based system in our region. These, in my opinion, are kind of a transitional technology. We can now do most of the things that we were doing with these with the cold climate heat pumps, but there are cases where these still have an application. Oftentimes, the places where we end up installing these are ones where the customer just recently put in a new gas furnace and so has a reluctance to tear it out completely, but may want to supplement with a cold climate, not a cold climate, a conventional heat pump. Another opportunity here is where someone is looking to just add central air, and we can offer them a heat pump instead of just a straight air conditioner, and in the process sometimes cut their fossil fuel by 50 to 70%. So we don't install as many of these, and the NYSERDA incentives don't really support them, but it's just good to know that these are out there for certain applications. Here is an example of one of these installed. We have the outdoor unit. It's up on heat pump legs to keep it out of the snow because it's going to be operating in colder weather. And here's the indoor unit. We have a high efficiency natural gas furnace. The indoor coil sits on top of that. And as you can see, we've enlarged the return ductwork because heat pumps need more airflow than fossil fuel equipment. So we're typically, you know, in almost all cases, we're doing some kind of ductwork modification to make sure that these are getting adequate airflow. Okay, so moving on to domestic hot water. A very popular product, we've been installing many of these, are heat pump water heaters. These run on 240 volt electricity, so in many cases they are a direct replacement for an existing electric water heater. They use the refrigerant cycle to extract heat from the air in the living space. Typically we want to put these in basements, not in the actual living space of the house, partially for noise considerations, and partially because they drop the temperature of the air around them by a couple degrees. So what these do is they pull in air from the surrounding space, they pass it over a coil that absorbs heat. Inside this is essentially a complete heat pump, including a compressor, evaporator, and the condensing coils that release the heat are down in the tank itself. These also have backup heating elements so that in times of high demand, they can fall back on conventional electric resistance. But when they're operating in heat pump mode, they are oftentimes 3 or more times more efficient than electric resistance. And so can cut people's electric heating, the portion of their bill that's for electric hot water significantly. They also represent a highly cost-effective replacement for people that are using propane or those rare cases that are using fuel oil to heat their hot water. And I'm going to just briefly touch on geothermal heat pumps. They are a great technology and they are worthy of entire course of their own. I am personally an air source person, that's my specialty, but I think it's worth knowing about these and offering them to customers when they make sense. So instead of extracting heat from the outdoor air, ground source heat pump systems extract heat from the ground. That can be a shallow loop, set of trenches. It can be a set of vertical wells. It can be a pond of sufficient size and depth. Ground source heat pumps, because they take advantage of the high heat transferability of the ground and the relatively constant temperatures of the ground, are more efficient than air source heat pumps. They really are a premium solution. They're expensive. For some applications, they are really a perfect solution. Because all the components are either inside the house or heavy duty plastic piping buried in the ground, the system has a very long lifetime. And they, in some cases, can provide capacity that allows you to use a single system to heat and cool a larger house than you would be able to do with a single air source heat pump. Geothermal systems can also produce domestic hot water. So there are cases where if you have a geothermal system, using it to also produce your domestic hot water is a really great solution. The main types of loops that we see are either these shallow trench loops with slinkies in them, or vertical wells. The trenches are less expensive, but they do require more available land, and they do create more ground disturbance. Vertical applications allow you to do this with minimal ground disturbance on a very small footprint, so that these are done sometimes even in urban settings. So to talk a little bit more about why and why we're doing this and why we're so excited about it. Heat pumps and air source heat pumps in particular offer a lot of social benefits. As we mentioned, because of the lack of combustion involved, they improve air quality both inside the house and outside. There's no carbon dioxide to contribute to global warming. Because of their efficiency relative to conventional air conditioners, including both central air conditioners and window air conditioners, they help with that peak of summer demand that occurs on about now on days like today, when air conditioners throughout the state all kick on at once and put a lot of strain on our distribution and our generation system. Because these air source heat pumps are so efficient, oftentimes with SEER ratings of 20 and up, they can reduce that summer demand peak. Installing heat pumps reduces the need to create and maintain more natural gas infrastructure. We're seeing in a lot of areas of our state resistance to new gas pipelines. Heat pumps allow us to eliminate the need for those gas pipelines in a lot of cases. They also allow us to avoid kind of more locally centered investments in infrastructure, like the gas pipeline that would go to a new house under construction. That's significant savings that can be taken off the initial cost of the house that can oftentimes offset the cost of installing the heat pump. Heat pumps can help to reduce the energy burden for low and moderate income households. One of the things that we're excited about, especially given some of the the recent economic disruption that's going on, is that installing these pumps, these heat pumps, is going to require the creation of a local trained and skilled workforce, jobs that can't be outsourced overseas. And these are skilled living wage jobs. And I think that's something that can really help to boost our local economies. And they also contribute to our larger efforts to cut our carbon emissions throughout New York. A lot of the benefits of these systems accrue directly to the homeowner. So in many cases, they're going to be reducing electric use and heating and cooling bills. They can directly resolve comfort issues like that freezing room over the garage. They can replace that noisy and marginally effective window air conditioner that you have to haul in and out every year. And they can make it possible to get that comfort heating to areas, parts of the house that weren't previously well served. As we mentioned, we can eliminate that carbon monoxide risk. And because of the flexibility of these systems, we can often find a way to integrate them into all kinds of spaces. You can see in this picture, the high wall unit is relatively discreet. I know that some people are able to tune them out, others will, other people can't. And some people will express, dead set opposition to any object like that hanging on their wall. And in that case, we have other options we can offer them, including ducted systems. Just to mention a couple common applications, the ductless systems like the high wall units often work very well when you have parts of the house that have open floor plans. So, your kitchen, living room area. The ductless systems oftentimes have horizontal throws of 30 plus feet. And so if the envelope is pretty good, you can serve an entire area with a single head. One of my personal favorite applications is to install heat pumps in a house that has electric baseboard. One of the things I like about that is that you can install a number of heat pumps that it's scaled to the homeowner's budget. So if they only have a budget to install a single heat pump, we can install that in the open floor plan area of the house. They can still rely on electric baseboard for the bedrooms. And in the process, you can still achieve a really significant reduction in their energy use. Another application that I think is going to be the one that really allows us to scale this is what I'm calling the box swap scenario. And it's usually not a simple box swap, but you are taking a cold climate heat pump and installing it in the place of the old furnace. And in the process, you're taking advantage of the existing ductwork to get conditioned air to all the rooms. Now, in almost every case where we do this, we do find that we need to do some modification of the ductwork. Invariably, we're increasing the size of the supply ducts so that we can increase the airflow that way. But we're also oftentimes adding additional supply runs just to make sure that we get adequate airflow through the system. Another application that we get a lot is people that built their house with the intention of heating entirely with wood. And it was great when they were young and their back was good. And now they find that they're busy, they're not quite as excited about hauling 3 or 4 cords of wood a year into their house. And so adding a ductless heat pump allows them to take a break from that, maybe get away from it entirely. And another application where we're finding that these make a lot of sense is a case where you've got an older steam or hot water boiler that needs to be replaced. If they were to simply install a new steam or hot water boiler, they wouldn't have any cooling. And they may or may not have the control they want over the temperatures in the rooms. So this is another place where air source heat pumps can make a lot of sense. I'm talking here about some of the things I refer to as green lights, things that make it a lot easier to get the homeowner to buy in, and oftentimes will lead to a very high closing rate when you make these proposals. We find that people that are transitioning away from expensive fuels oftentimes see a lot of value in air source heat pumps. And being able to show them that these projects can provide really significant savings is an important thing. It can make even more sense when the existing equipment is approaching the end of its lifespan. So they're looking at making a major investment in new heating equipment, new heating and cooling equipment anyway. And the incremental cost of switching over to a heat pump is going to be a lot less than if they were just tearing out a new and well-functioning system. Another big selling point of these is the need to, or the desire to add cooling. And I think over the summer, that's been really brought home to a lot of people, how nice it would be to have a quiet, efficient, and well-controlled cooling in their house. And we're finding that, at least in our market, increasing number of our customers are driven by environmental considerations. These are people that, are conscious consumers. They're thinking about the food they eat and the car they drive, and installing heat pumps just make a lot of sense in terms of their environmental commitment. So these are all things that I consider to be green lights. The barrier to the sale is almost always cost. There are cases where we just because of the unique characteristics of the house, we just don't have the right solution. But most of the time, the barrier is cost. And New York State incentives and financing are really terrific tools to remove some of those barriers to the sale. I know that a lot of our audience comes from a home performance background, and I just want to emphasize how valuable the skills we've learned as energy auditors and home performance contractors are to making this all work well. The key to a successful heat pump installation starts with good load calculations. By right-sizing the system, we can avoid oversizing it, which not only will keep our first costs down, but will make the system perform better in the long run. This is one of our energy auditors, Sarah, and she's there with a couple of the tools of the trade. The blower door, one of the biggest variables in any heat load calculation is the air leakage of the house. And being able to measure that accurately allows you to really get your heat load calculations dialed in. Right now, because of the concerns around COVID, we have had to put our blower door work on pause, but we're hoping to be able to resume that sometime in the near future. The infrared scanner also greatly reduces the amount of guesswork you have to do about insulation levels in the walls and other inaccessible building assemblies. So there are cases where some simple shell measures can make a lot of sense and bring that heat load down significantly. In a lot of cases, we're combining this heat pump work with air sealing and insulating the attic and dealing with kind of the low-hanging fruit that we find in the basement, whether it's leaky rim joist or a vented crawl space. So addressing those low-hanging shell measures in a way that doesn't go over the top like we were doing with the deep energy retrofits can really make these heat pumps work a lot better. And then a key point, and I think there's just a lot of work that still needs to be done here, is homeowner education. And the energy audit provides an entry point for that. It allows us to help start to familiarize them with the technology, promote the benefits, and discuss the rebates and incentives that are available. I want to really quickly go through some of the current incentives. All of this is going to be in this link, which will be sent out with the talk. But right now, the New York State Clean Heat Program, which is statewide, but administered through your local utilities like NYSEG and National Grid, provides $500 per outdoor unit for partial load solutions. Those are ones where the equipment doesn't meet a minimum of 90% of the heat load of the house. And for whole home solutions that meet the full load, they provide $1,000 per 10,000 BTUs of capacity. The heat pumps, the incentives are higher for ground source heat pumps. They're $1,500 per 10,000 BTUs, and that reflects the extra efficiency that you get out of ground source heat pumps. And heat pump water heaters are eligible for an incentive of $700 each. So that can take a big chunk out of the cost and really help to even the playing field. These utility incentives can be combined with the NYSERDA residential programs. And this is where we can really offer homeowners some really deep discounts and some really great financing. For homeowners that are below 120% of the area median income, so this is actually more than half the occupants of any area fall in this category. They're eligible for a 50% matching grant up to $5,000. And this can be stacked with those utility incentives. So you now are having, $1,000 per 10,000 BTUs plus $5,000. And then once you subtract out all these incentives, you can finance what's left using a low interest loan. For low to moderate income homeowners, they'll be able to get this 3.49% interest rate. I just wanted to take you through a real quick case study to show how we can take a expensive project, a $15,000 heat pump replacement that provided a replacement of an oil boiler and an indirect tank with a 3-head ductless heat pump and heat pump water heater. When we subtract out the air source heat pump rebate, the heat pump water heater rebate, the assisted home performance, and we had some additional incentives that were available through our local HeatSmart Tompkins program. Now this $15,000 cost is under $5,000. And when we finance that over 15 years, the monthly cost is $34. Now, that's her loan cost. Her monthly oil savings were over $60, so that each month she's achieving a net savings of $27. This case study is described in a lot more detail in the HeatSmart Tompkins website. And I will just say that these aren't theoretical savings. These are measured savings. We went back and looked at the removed oil costs and the increase in electric costs as a result of this project. The Comfort Home program is a program that is just recently being launched by NYSERDA. It is in a pilot stage, so it's not available statewide. But what they are trying to do here is provide some incentives for homeowners that are above that 120% of area median income and so aren't able to take advantage of the assisted home performance. This program provides incentives for doing envelope improvements that can reduce the heat load of the house. And these can lead to incentives of up to $6,000. To qualify for that $6,000 level, you have to do very extensive improvements, including window upgrades. Most people are ending up with lower levels of incentives. But this is one more thing that if you're interested in participating in this program, you can put together a really nice package for your customers. I'm mainly focused on the residential market, but there are some great options and great opportunities here in the commercial realm. The savings can be really great when you're offsetting, again, those expensive fuels, but a lot of the advantages relate to providing high quality cooling to make spaces more productive and enjoyable to be in, and allowing situations where you've got a landlord and then subleasees or different offices to achieve finer grained control of your temperatures with individual heat pump units. Now, as always, when you're dealing in commercial settings, you need to be prepared to talk costs and payback and return on investment. And that's where getting familiar with some of these calculations is going to be really valuable. So the next few slides relate to directions that we're going to be offering in the next couple webinars in this series and in the hands-on training. Because of the ambitious goals of getting heat pumps into the 5 million homes in New York State, we're going to need to dramatically grow this workforce. And if we want to achieve a lot of buy-in and satisfaction from homeowners, we're going to need to make sure that these go well, that these systems are properly designed and properly installed. And that's what part of what this effort is all about. It's really critical that everyone who's involved, from the design to the installation to the customer education and the maintenance of these systems, is fully trained. And that's what we're pushing for here. Design is really critical. What we're finding is that to get good results out of these systems, you really have to think carefully about the application that you're using. Make sure that it's a good match for the equipment that you're choosing, that you've done thorough sizing calculations, that you've thought through a couple different alternative scenarios. Where do you want to use ductless heads? Where do you want to use compact ducted systems or fully ducted systems? And that you also have a good control strategy in cases where you're integrating with an existing system, whether it's an electric baseboard or a boiler. You want to make sure that that control integration is done in such a way that it reduces energy costs and improves comfort. And then there are opportunities too with home automation to allow things like heat pumps that can be controlled and monitored through your phone, for example. This is something that I'm especially passionate about talking about, is the importance of getting really high quality installation. And there's lots and lots of ways to to mess these things up. And yet the knowledge is out there and the experience is out there to make sure that these are done right and they work well every time. We need to pick good locations and mount these units properly, and that includes things like making sure they're not going to vibrate and cause noise, that they're not going to be in locations where water is dripping on them excessively or snow buildup is a problem. We need to be meticulous about getting the refrigerant piping right. The number one callback in all these systems has nothing to do with the manufacturing. The equipment is very, very durable and has very few breakdowns. The number one callback is related to refrigerant leaks. And we need to have good procedures, good systems in place to make sure that we do a good job of keeping those refrigerant lines tight. Not just so that the systems work, but so that refrigerant doesn't leak out into the environment and cause just the problems we're trying to prevent. And then there's also things that you need to know about the electrical setup and the balance of systems, like the controls and the line hides. And we're working on developing some best practices around testing and commissioning of these systems as well. And as I mentioned before, these systems will work great when they're installed. And in order to keep them working great, we need to make sure that we place a focus on proper operation and maintenance of these systems. A big opportunity is better customer education. And oftentimes, people that are good at installing these things are not necessarily educators. And so we need to find a better way to make sure that homeowners are operating these as recommended. We need to make sure that they're getting proper preventive maintenance. Sometimes, preventive maintenance is a general problem for all residential HVAC, but with these systems in particular, we want to make sure that we've educated homeowners to do the maintenance that they need to do, and then to get us in there every year to do a full maintenance. And then there's a lot to be learned about troubleshooting and warranty and repairs. Again, as I mentioned, I think these systems, they tend to have very few breakdowns if they're installed properly and and maintained over time. The next webinar is going to be the same time, a week from today, and we're going to be looking at the air source heat pump as an integral part of a comfortable and energy efficient home. So a lot of what we're going to be doing in the next webinar is looking at how you might transition from the role of a home performance contractor or a conventional HVAC contractor, how you might start adding air source heat pumps to your offerings. And we'll look at that from a sales perspective, from a training perspective, and just a general kind of operational perspective. So I hope you all will enjoy, that you'll be able to join us for that, and that you'll pass that on to anyone who you think might be interested. And then in the last webinar, 2 weeks from today, we're going to really drill into best practices around installation and look at how we can get these systems installed without callbacks. There is a lot of ways to mess these systems up. And so we're going to go through some of the most common ones so that you can learn from from my mistakes. So please go ahead and register for those. And then I am really excited about this hands-on workshop. This is going to be held at the Snug Planet offices. We are going to be installing a new ductless air source heat pump from scratch. And so it's going to be a chance to actually get your hands on and learn how to flare copper and install line hide and all the pieces that go into a full installation. This is going to be limited to 8 participants, and we are going to be following COVID safe protocols of masks and social distancing for the whole time. And with that, we'll say thank you for attending and turn it back over to Conrad.
Hey, great. John, can you hear me?
Yes, I can.
Okay, very good. We do have quite a few questions, and we can get through them pretty fast, I think. On slide 11, you had a chart on the cost per 100,000 BTUs of the different options. Do you know if those are from actual numbers from energy bills, or are those theoretical based on COP versus AFUE?
So that chart was based on using the standard NYSERDA pricing that NYSERDA has us use for the central region and the NYSEG utility area, and then derated by the AFUE. So those are calculated numbers. Those aren't measured numbers. We do have some measured performance numbers. I didn't have the chance to put them all into a graph like that.
Right. Okay, very good. Have you personally, in your work, have you done before and after bill comparisons?
Yeah, we have. You know, we haven't done as much as we would like, but we are in the middle of a pretty extensive project where we're going back and actually scraping data from dozens of homes to look at before and after savings. We've done a limited number of case studies. One of them is on the HeatSmart Tompkins website that was based on that case study that I presented.
Mm-hmm. Very good. Another question, what is the minimum load of the house required to be for the $500 incentive? Is there a minimum load requirement? There
is none. No, it is simply based on installing a heat pump that is it's one of the high efficiency cold climate heat pumps that's listed on the NEEP list. You do have to be a participating contractor in the program and fill out the incentive application.
Right, of course. Do you know of heat pumps that offer UV lighting for air purification, which is an interesting idea that I've never heard of before, but especially when we're talking about, you know, the home becomes kind of a closed loop system, I think. And so, yeah, how are we purifying the homes? And I know maintenance is one of the answers to how are we purifying the air. And maintenance is going to be, I think, a huge aspect of this move forward. But do you know of any heat pumps that offer UV lighting for air purification?
Yeah, that's a great question. There are none that I know of that offer it as a standard feature, but there is a UV light that fits right inside the blower cabinet that can be installed as an aftermarket measure. And I can't remember the name of it right off, but it is one of the major UV light manufacturers.
Yeah, interesting. Yeah, I think that sounds like an interesting, you know, almost COVID marketable.
Yeah, you know, this is one of the things we're very interested in what we can do as HVAC contractors to help out. And a lot of the things that we recommend to reduce the spread of COVID in buildings are the same things we'd recommend for general indoor air quality. Ventilation, but maybe we need to start upping the ventilation rate even more than we would under normal circumstances. Filtration, we need to start looking at MERV 13 plus filtration. And then keeping the humidity in the healthy range also can help reduce the transmission of the virus and the lifespan of the virus.
Yeah, very good. And so how is ventilation dealt with? Because I can see that, you're running your air source heat pump pretty much all the time. And so are you subscribing to the standard ventilation requirements? And do you have to create those holes or, or unseal your windows or anything like that?
Right, right. So I think one of the things we're realizing is that we need to do a lot more about indoor air quality in homes. And there's a couple different ways that you can do that. If you're going with a ductless system, for the most part, you're going to need a separate set of equipment to provide ventilation. And historically, we had used heat recovery ventilators, energy recovery ventilators. I think we're getting more and more excited about the idea of a ventilating dehumidifier.
Uh-huh.
That is essentially a dehumidifier which provides a controlled mixture of indoor air and outdoor air. And so you're getting that fresh air to dilute contaminants, but you're also reducing the humidity as you're bringing it in and keeping it down in a healthy range. If you have a ducted air source heat pump, especially a one that has enough static pressure to incorporate a filter and other components, you can actually tie your HRV or your ventilating dehumidifier into your ductwork and distribute the air that way.
Right. Very good. Here's an interesting question about customer concerns. Are customers convinced? Are they concerned about comfort during the heating system due to essentially lower air temperatures and higher flows when compared to fossil fuels?
Right. That's definitely a conversation that needs to be had with homeowners. With proper design and proper sizing of the system, your equipment should be able to maintain a comfortable temperature in the house. So that has to be dealt with as part of your design. But you also need to talk to people about the fact that they're used to fossil fuel furnaces that could deliver 140, 150 degree supply air, and heat pumps are delivering much lower supply air temperatures, typically 110, 115, and so it feels different, and it may take some getting used to, but I think that's why it's really important to have these conversations with homeowners. This is going to feel different. And just be aware of that going into this, so you can anticipate some of the concerns.
Yeah, very good. Do you know offhand if the NEEP website, I'm pretty sure the NEEP website has a list of the tools that a home performance contractor would need if he was getting into installation of air source heat pumps. Can you confirm that? I think that's true, but I don't know of it.
I don't know about that specifically. I do know that LG in particular has an excellent installer training where they go through all that. But if you're transitioning from conventional HVAC, then you're going to need essentially all the tools that you would need as an air conditioning contractor: manifold gauges, vacuum pump, micron gauge, flaring equipment, and so forth. If you're transitioning from a different trade entirely, you're going to have to make a significant but not insurmountable investment in tools. It's much less than it would cost you to become say a home performance contractor.
Right. Very good. So yeah, if you're interested in seeing those tools, you should sign up for the hands-on workshop. Okay. Here's a timely question. We noticed that much of the coast, much of New York City is out of power today because of the storm that went through last night. Does an air source heat pump always require a backup heating source?
Yeah, so almost none of the houses in our region have heating systems that can function without power. You know, when we think about what can function without power, we are looking at a wood stove, a propane type stove that doesn't have any blower fans in it. So your existing furnace and boiler require electricity to operate. So it wouldn't just be air source heat pumps that would be knocked out by a large power outage. It would be a lot of the fossil fuel equipment as well.
Good.
We encourage homeowners to have some kind of backup system, just because these are, you know, they're complex pieces of technology, and parts may be, you know, may take a couple days to get. And so I think especially in areas that are especially prone to power outages, like rural homes at the end of long wooded driveways, it makes sense to have either a backup generator or a wood stove or something like that to get you through a couple days.
Mm-hmm. Right. So really the perfect home for an air source heat pump is a home where the heating system is not new, but doesn't need to be replaced yet. Perhaps it has 5 more years on it. And what we want to do is extend that to 15 or 20 years by pulling in an air source heat pump. That's the way I would look at it.
Yeah, I think that's a great question. I think there's different ways that could be approached. Some people would feel more comfortable keeping their existing fossil fuel system there as a backup. We are just in the process of this in my house. We finally are getting around to installing an air source heat pump in our own house. So we just have been too busy installing them in other people's houses. But we decided to shut our gas meter off entirely. And so we have an air source heat pump that is actually, it's on back order right now. We already have our heat pump water heater. We electrified our cooking and our dryer. And if we have an extended power outage, we're going to fire up our wood stove.
Right. Right. That makes sense. Another question here. Are there certain brands, or is there a specific SEER number that you got to get to qualify for utility rebates? And the question may even apply to the NYSERDA Comfort Home Program. And where is this information available?
That is a great question, and I should add that in the mailing. But the list that tells you what equipment is going to qualify is at the Northeast Energy Efficiency Partnership, NEEP, and the equipment has to be on the NEEP cold climate list.
Okay.
And so what you'll see is that the major manufacturers that you're familiar with, Mitsubishi, Fujitsu, Daikin, and so on, are going to be on that list, as well as there is some other manufacturers that do have equipment that would qualify, like American Standard. So you can go to that list and look at equipment. And it's not all Mitsubishi, for example, that'll qualify. It's only their cold climate products.
Good point. So yeah, for those that are interested, most of the manufacturers have training available, and you have to work through the manufacturers. It's hard to get that information, actually. It has been for me to get it, but it may not be hard for an HVAC contractor to get it. Yes, someone just provided the link to the NEEP page that we were talking about. And so that's in the chat window for all you all to see. And I think the last question here is something I'd typically just respond privately. But someone asks if there are only 8 people allowed for the hands-on training. How come it's only a 1-day training? And so I'll just answer that. Yes, we'd like to offer it several times because but we want to keep it small because that's how training really happens. We want everyone to get hands-on training, and we want everybody's hands on that. COVID-19 presents an unusual challenge there, so we are limiting these, but we will probably offer it more than once, and that depends on demand. So.
Yeah, I mean, there's a couple special challenges that we faced this time around. One is that given the issues with COVID, it was very hard to do this in someone's house. And so we had a project on the back burner here at our shop that we're gonna move up. And we also have a nice space here to sit down and meet and train as part of that. But I think it's our hope to see if we can identify some funding that would allow us to create a mobile training space with a setup that would allow people to, you know, assemble and disassemble one of these systems and kind of take the show on the road.
Yeah, that would be great. Okay, and to answer, I think, the last question we have, yes, this session was recorded. I am not sure where the link is, but we will make sure that all attendees get that link one way or another. This is our first Zoom webinar, so my first Zoom webinar, so I'm not quite sure where that link will be, but we'll make sure that all the attendees get that. And I think that about wraps us up. We're 8 minutes ahead of schedule, so if anybody had any additional questions, yes, here's the answer to the question that I just couldn't answer myself. That link will be hosted at HeatSmartTompkins.org. So they are creating an archive of webinars, and those are available to everyone. So that's we may send out that link, but I think that's where you can go. There's lots of good information at HeatSmartTompkins.org. And so I think we are about wrapped up. Thank you so much, John, for your presentation today. Let me also just appreciate the ongoing work that you're doing to promote energy efficiency and to build up the home performance industry. I really do appreciate that. And I would encourage our attendees to register for the other 2 webinars in this series if you're not already done so. If you are an installer already, I guarantee you'll benefit from the hands-on workshop that John will be leading on August 22nd in Ithaca, New York. Yeah, so I urge you to sign up because the more people we have that sign up, the more times we can try to figure out how to offer that. Very good. If there's still questions, which I see none, but if you have any, feel free to respond via email. Today, our time is just about up. Thanks for your participation. Feel free to reach out whenever necessary. And thank you again, John. Thank you, Brian Eden. And this is Conrad Metcalf signing off.